Okay, so this question says, determine the moment of inertia for shaded area shown in respect to x and y axis. Okay, so what we have to do right here is that we know that there are some empty spaces. So okay, so what we're gonna do is that I'm gonna consider the entire rectangle as segment 1, and then this upper empty space as segment 2, and the lower empty space as segment 3. Okay, so and then I have the table list up right here, and then what I have to do at this point, just fill out all the missing point that I needed. So first thing is I have to calculate the area for 1. So 1 is the entire rectangle, right? Okay, so entire distance right is 5 inches. This distance right here is 6 inches. Okay, so that's simply just 5 multiplied by 6, which is 30. Okay, and then for 2, which is 2 multiplied by 4, well, I can say 4 multiplied by 2. Okay, because the width is 2 plus 2 and the height is 4. Okay, okay, 8. Okay, and then third missing part is will be 4 multiplied by 1, which would be 4. Okay, so you could put a negative value here, but I'm not going to put it right here because I know at the end I'm just going to subtract them. So I just want to keep them positive throughout and then just subtract them at the end. Okay, so I'm just going to keep them positive. X, that is the centroid. Well, we know that for a rectangular shape, even though this is a composite body, but if you consider this entire composite body as a rectangle, then we know that the centroid of this thing will be in the middle, right? Okay, and then we know that x bar and y bar, those are the distance. Okay, x and y distance. Well, we know that this is a rectangle, right? Two, right? Segment 2 is a rectangle too, so it's centrally going to be right here. 3 right here, same. They are along the same y-axis, which means that the x bar will be 0. Okay. And then for the y bar is a little different. So for the y bar, entire composite body. So for segment 1, the y bar will be 0 because we know that y bar is the distance from this segment to the origin, but this segment 1 right here is already the uh, the center of the composite body. So its x bar and y bar will be 0. Okay, but for segment 2, we have to consider this 1 inch, okay, and also 1/2 of 2 inch, which will be 1 inch right here because this will be the y bar, okay, because this is the centroid of segment 2. So that will be 1 plus 1, which will be 2. Okay, and then for segment 3, it's the same thing. So we'll have to consider this distance 1 inch right here, and also half of this because the centroid is going to be right here, so 0.5 right here. So it'll be 1 plus 0.5, okay, which will be 1.5. Okay, like I said, I'm just going to keep them positive throughout because I know I'm going to subtract them at the end. Next is the x bar x and y bar x. Okay, so what this means is that I know that x bar x is equal to, because this is a rectangle. Then we know that the equation for moment of inertia for a rectangle is b high multiplied by height cube divided by 12, right? That is for the excuse me I x bar, and then for the I y bar, though it'll be the flipped it. So it'll be h multiplied by b cube over 12. So I want you guys to remember that. Okay, so for I bar x, that is the b multiplied by the h cube divided by 12. But for I y bar, I bar y, it will be h multiplied by b cube divided by 12. Okay, so ix here. Well, let me just make it more space. So this one will be, the base will be 5, right? 5 multiplied by 6 cubed over 12. because segment 1, the base is 5 and the height is the 6 inch, right? So that would be 90. Okay, that's inch fourth. Same for these two. All right, and then for the segment 2, it will be, so the base will be 4 multiplied by 2 squared over 12, which that will be 2.67. Okay, and then for the segment 3, it will be 4 multiplied by 1 cube over, oh, my bad, right here. Here should be cube, not square. Okay, 1 cube, and then divided by 12, which that would be 0.33, right? And then for the I bar y, same thing, but just flip these two values. So it'll be 6 multiplied by 5 cube over 12. It'll be 62.5. Okay. And then for the segment 2, be 2 multiplied by 4 squared over 12, which would be 10.67. And then for segment 3, okay. All right, so we find out our Ix bar and the, I bar X and I bar Y, and now we have to find what is the actual Ix and Iy. Those, the equations are shown right here. Okay. So let's find out what Ix and Iy is. So for 1, we know that it will be the Ix, which will be 90, plus the area. So the area is not for the entire composite body. It's only for this segment. Well, for segment 1, the area we find out right here is 30, right? So 30, and then multiplied by the dy, which is the perpendicular distance for the centroid of this segment to the center of the composite body. Well, we know that for segment 1, since it's for the segment 1, its centroid is also the centroid for the composite body, so which means that the perpendicular distance will be 0. Okay, because segment 1's centroid is the centroid of the entire composite body, so there is no distance between it. Okay, so that's why I consider 1. Okay, and then so this Ix will be 90 inch fourth, and then Iy, same thing, which I have 62.5 plus 30, which is the area for 1, and then same thing for the dy, which will be 0. Okay, so that will be also 62.5. So 90, 62.5. All right, and then let's consider segment 2. Okay, so for the segment 2, it is 2.67 plus the area, which will be A. All right, and plus the dy. Okay, so dy right here will be this one right here, from, because this is the centroid of the entire composite body, right? And then this is the centroid of the try better. So here is the centroid of segment 2, right? And the distance between them is 2, right? dy, so along the y-axis will be 2 inches, right? So 2 square, and then I got that as 34.67 inch fourth. And then Iy, same thing. So that would be 10 point. Which will be 10.67 plus the area, which is A, and then the dx, which will be this distance dx right here. Well, we know that there's no dx between segment 2 and between the centroid of the segment 2 and the centroid of the entire composite body, because because the centroid of segment 2 is along the same axis as the centroid for the entire composite body, right? So when they are along the same axis, so that means that the perpendicular distance in the x direction will be 0. Okay, so 0 squared So that will be 10.67 inch fourth. All right. And then let's find out segment 3 right here. Segment 3 will be 0.33, which is the I bar x plus the area, which will be 4, okay, and then multiply by the dy, okay, which that dy will be right here. Dy will be right here, which will be this is 1 inch, right? And this is 0.5 inch. Okay, because that's between, because, let me zoom in. Because that is the distance between the centroid of segment 3 and the centroid of the entire composite body, okay? So I got 1.5 right here, square, and then that will be 9.33 inch fourth. And then for the IY, so that will be 5.33 plus area 4, and then multiply by the dx. Well, we know that they're along the same y-axis. They're essentially along the same y-axis, so which means that they will not have a dx. Okay, so that'll be 5.33 also. All right, and then just fill that into the table. 34.67, 10.67, 9.33, 5.33. Okay, so what I'm gonna do at this point is that just take Ix. So the final Ix will be, so final moment of inertia along the x direction will be the Ix1 minus Ix2 and minus Ix3, because Ix2, because segment 2 and 3, they're empty space. Okay, they're not solid matter right there. So that's why I didn't consider them as positive, I mean, as a negative value while doing this table. But at the end, I'm gonna subtract it, okay? So that would be, this one will be 90 minus 34.67 minus 9.33. Let me see what I got. So I got Ix is equal to 46 inch fourth. And then same thing for Iy. So Iy is 62.5. 62.5 minus 10.67 minus 5.33. Okay, and I got my Ayy equal to, see, 46.5 inch fourth. Okay, so this will be the final value.